Okay, before we start going over the worksheet that we did in class today, I'm going to remind you of a couple of things about the things that we talked about this week. We have percent composition, we have empirical formulas, and molecular formulas. Okay, so we're going to start off by talking about percent composition first. So, percent composition is basically the total mass of an element divided by the total mass of the compound, and then you multiply by 100 to get the percent. So you just have to remember that if I have something like calcium phosphide, that there are in this compound 3 calciums, so I'd take the mass of the periodic table from calcium, multiply it by 3, and there are 2 phosphorus, so I take the mass of phosphorus, multiply by 2. So for the percent composition of calcium here, I would want the total mass of calcium, so that would be the mass of calcium times 3, divided by the total mass, which would be the mass of calcium times 3, plus the mass of phosphorus times 2. That's your total mass. So that's a quick, brief review of percent composition. Okay, so for empirical formulas now, we're going to come over this way. Empirical formulas, there are 3 steps. Step 1, you're going to divide the mass of the element in the problem, divide that by the mass on the periodic table. Okay, that's going to tell you the number of moles that you have. Now, we haven't talked about moles, but that's what it is. Then you're going to, that's step 1. Step 2. After you divide that mass, you're going to take your answers from that and divide by the smallest. All right, and if all of those answers are whole numbers, then you're done, and your answers become the subscripts of your formula. If they're not whole numbers, then you do step 3, which is to multiply them so that you can get whole numbers. Now, when you're doing that, you have to consider the fact that things like 0.5 means a half. 0.3 repeating means a third. 0.25 is a fourth. So if I have these decimals like this, and I want to get rid of them, to get rid of a half, I have to multiply by 2. To get rid of the third, I multiply by 3. To get rid of the fourth, I multiply by 4. So that's how you can help yourself figure out what I'm going to multiply by in order to get my empirical formula. Okay, so now we're going to come back, and now we're going to look at molecular formulas. So molecular formulas, first you have to get the empirical formula, and that means we're going to have to do all of the stuff that we just talked about in green over there. And the molecular formula, you take the mass of the compound and divide by the mass of the empirical formula. And that's going to give you an answer. We call that answer N. So then you're going to take N and multiply that by the subscripts of the empirical formula. And that's going to give you the molecular formula. So that is a very, very quick, very, very fast review of the things that we have gone over this week. And now we are about to start going over the worksheet. So if you have that paper from today in class ready, you can look at it. If not, then just follow along on the screen. So question 1 said, what is the percent composition of H2O2? So in order to do that, we got percent composition. I'm going to move this over here out of the way so we can still see the question. But for percent composition, first thing we need to do is find the mass of each element. Well, hydrogen has a mass of 1.008, and oxygen has a mass of 15.999. Now in this particular problem, you see that there are 2 hydrogens and there are 2 oxygens. So I'm going to take each of these and multiply them by 2 because I have a total mass of 2 of each of them. Now that gives you a mass of hydrogen of 2.016 and a mass of oxygen of 31.998. So when I add those together to get the total mass of the compound, that gives me a mass of 34.014. So this is my total mass of my compound. So to find the percent composition, I have to take the total mass of each element and divide by that. So the percent hydrogen is going to be 2.016 divided by my total mass of 34.014. And then, of course, since it's a percentage, I have to multiply by 100. And that gives me a percent of hydrogen that is equal to 5.9%. So when I then do the same thing with my oxygen, I'm going to take the total mass of my oxygen to get my percent oxygen. I take my total mass of 31.998 and divide by 34.014, and I multiply by 100 because it's a percent, giving me a percent of oxygen equal to 94.07. So if we go back, we have our question, what is the percent composition of hydrogen peroxide, which is what H2O2 is. My hydrogen is 5.9%, and my oxygen is, as we just saw, 94.07. Or 94.1%. You'll see 94.1 and 5.9 add up to 100. So that is that. All right, number 2, what is the percent composition of nitrous acid? Find the correct formula first. So let's do that. Nitrous acid, it is an acid, so that means it starts with hydrogen. And nitrous means it doesn't say hydro nitrous, it says nitrous. So not saying hydro means we look at our polyatomic ion list. The OUS means it came from the ite form or the ITE form of the polyatomic ion. So this is nitrite, which is NO2. So HNO2 is our nitrous acid. So now I'm going to do exactly what I did on the last problem to find the total mass. The total mass of this is going to be, well, hydrogen is 1.008. There's one hydrogen. Then I have nitrogen, which has a mass of 14.007, and there's one nitrogen. And then I have a mass of oxygen, which is 15.999, and there are two of those. So if I do this and add it all together in my calculator, then I get a total mass of 47.013. So this is my total mass. So then to find the percent composition, my percent hydrogen is going to be my hydrogen, 1.008, divided by my total mass, 47.013, times 100, which is 2.14%. And then my percent nitrogen is going to be 14.007 divided by my total mass of 47.013 times 100, which is 29.79%. And then my oxygen is going to be my total mass of oxygen, which is the 15.999 times 2, which happens to be 31.998, divided by my total mass, 47.013 times 100, which is 68.06%. So now we have our percent composition here. The percent of hydrogen is 2.14, nitrogen 29.79, and oxygen 68.06. So that would be my percent composition of nitrous acid. Number 3, determine the empirical formula for a compound that contains 35.98% aluminum and 64.02% sulfur. So for a problem like this, if I give you the percentages like that, then you can assume that you have 100 grams of the substance. If I have 100 grams of the compound, then 35.98 grams of that 100 are aluminum. So the first step of finding an empirical formula is to take the mass of your elements and divide by the mass on the periodic table. So if I assume I have 100 grams, then I have aluminum and I have sulfur. And these are the masses of those elements that I have, and I'm going to divide each of them by their masses on the periodic table. Aluminum's mass is 26.982, and sulfur's mass is 32.066. So I take those and I do that division. And that gives me a number here of 1.33 for aluminum. And that gives me an answer of 1.99 for sulfur. So now what I do, after I have divided the mass that they gave me by the mass on the periodic table, I'm going to divide each of these by the smallest number, which is 1.33. Now you do this because you're trying to find a ratio, and that gives me one of these is going to equal 1. Okay, so when I do this division, that gives me an answer of 1.5. So now this is a whole number here. This is not a whole number, it's 1.5, and the decimal didn't show up very well. So it's 1.5. So I'm going to have to multiply this by 2, which gives me a 3. But if I multiply that one by 2, I have to multiply this one by 2 also, which gives me a 2. So these are now the subscripts for my empirical formula. So I have aluminum with a subscript of 2 and sulfur with a subscript of 3. And this is the empirical formula for that compound. Number 4, what is the empirical formula for a compound that is 10.89% magnesium, 31.77% chlorine, and 57.34% oxygen? So this is, again, just like the last problem, except we have 3 compounds now, or 3 elements now instead of just 2. So we're going to take, assuming again that we have 100 grams, that means my magnesium is 10.89, and divide that by the mass of magnesium on the periodic table, which is 24.305. It gives me an answer of 0.44. And then we have chlorine, which is 31.77 grams of chlorine divided by its mass on the periodic table, which is 35.453. And that gives us an answer of 0.896. And then I have oxygen, and there's 57.34 grams of oxygen. And I divide that by the mass of oxygen, 15.999, and that gives me 3.58. Now I'm going to divide all of these by the smallest. Well, the smallest one is 0.44, so divide all of those by 0.44. Like so. And of course, 0.44 divided by 0.44 gives you magnesium down here of 1, and then chlorine is going to be 0.896 divided by 0.44, which gives you 2.03, which you can just round to 2 because it's close enough to a whole number, and since we rounded things off earlier, that's fine. And then oxygen, we have 3.58 divided by 0.44, and that gives us an answer of 8, 0.1, which can round to just 8. So we don't have to multiply by anything because they're all whole numbers. So our empirical formula is simply MgCl2O8. That is the empirical formula. It's not actually the way the formula would work, but that is how we get it doing this, and there's a little bit more involved, which we could talk about at a later date. Okay, number 5. A compound was found to contain 49.98 grams of carbon and 10.47 grams of hydrogen. The molar mass of the compound is 58.12 grams per mole. Determine the empirical and molecular formulas. So empirical and molecular formula for this. So there's 2 parts to this problem. We're going to start off by doing the empirical formula the same way that we did the last couple of them. So we have carbon, and it gave us a mass of 49.98. We're going to divide that by the mass on the periodic table. And hydrogen, and it gave us a mass of 10.47. We're going to divide that by its mass from the periodic table, and that gives us our answers of 4.16 for carbon and 10.38 for hydrogen. So now we're going to divide both of these by the one that's smaller, which is 4.16. Divide both of them by 4.16 to give us an answer for carbon of 1, and hydrogen gets a value of 2.5. Now these are not whole numbers, so 2.5, 0.5 means I'm going to multiply by 2, giving me 5, which means I multiply this one by 2, giving me 2. So now my empirical formula, the empirical formula is C2H5. So in order to find the molecular formula, I have to know the mass of my empirical formula. So to find the mass of my empirical formula, I first have to take the mass of carbon, 12.011, and multiply that by 2 because there are 2 of them. And then I have to add that to the mass of hydrogen, 1.008, and multiply that by 5 because there are 5 of them. So when I do that, I get an answer of 29.062. So this is my mass of my empirical formula. So to find my molecular formula, molecular formula, I have to take the mass that they give me in the problem, which is 58.12, and divide that by the mass of my empirical formula, which is 29.062, and that gives me an answer of 1.99, which is roughly 2. So my molecular formula then is I'm going to take my 2 that I got here and multiply my subscripts by 2. So my molecular formula is C4H10. So that's how we get empirical and molecular formulas from the information given. Question 6. A colorless liquid composed of 46.68% nitrogen and 53.32% oxygen has a molar mass of 60.01 grams per mole. What is the empirical and molecular formula? This is exactly the same as the one we just did, except they gave me percentages, which it doesn't really matter. I'm just going to keep it as masses. So we're going to say 46.68, and that's nitrogen, so I'm going to divide by 14.007 to get the mass of moles of nitrogen. And that gives me 3.33. And then for the oxygen, I do 53.32 and divide that by 15.999, and that gives me an answer of 3.33 as well. So then I'm going to divide by the smallest, which is 3.33 for both of them. So that means each of those equals 1. So that means my subscripts in my empirical formula, the empirical formula have subscripts of N1O1. So it's just NO. So the mass of my empirical formula is simply the mass of nitrogen plus the mass of oxygen. Simply add those two together. And that gives you a mass of 30.006. So that's the mass of my empirical formula. So then to find my molecular formula, I take the mass that they gave me in the problem right here, 60.01, divide that by the mass of my empirical formula, 30.006, and you should notice that 60 divided by 30 is pretty much 2. So then I'm going to take for my molecular formula, I'm going to take my empirical formula and multiply by 2. So that gives me N2O2. And so that's my molecular formula and empirical formula for that problem. Now for question 7, it was not in the file that I had uploaded to my program here, so I don't have a printout of it, but it was calcium is combined with phosphorus phosphoric acid, and we had to predict the products and write the balanced equation. Well, calcium is pretty easy. It's simply calcium. Phosphoric acid is the part that a lot of people have problems with. It is an acid, so it starts with hydrogen. Since the name does not say phosphoric, does not say hydro, it just says phosphoric. If it said hydrophosphoric, then I would look at the periodic table. But phosphoric acid, I look at the polyatomic ion list. And when it ends in ic, we go with the 8th form of the polyatomic ion, which is phosphate, PO4, which has a charge of -3. And when I cross my charges, then that gives me a formula of H3PO4. So this is calcium plus phosphoric acid produces, now we know that this is a single replacement because I have an element plus a compound. So calcium is going to replace the hydrogen because calcium is positive, hydrogen is positive. So calcium replaces the hydrogen. So when they switch places, that gives me calcium is now combined with the phosphate, and hydrogen is now by itself. Now when hydrogen is by itself, because it's one of those special 7 elements, it gets a subscript of 2, and calcium has a charge of +2, phosphate has a charge of -3, so when you cross the charges, it becomes Ca3PO42. So now I have to balance it. Since I have over here 1 calcium and over here I have 3 calciums, I know I'm going to need to put a 3 in front of my calcium. That doesn't really help me a whole lot. Now, I do know also that I have 2 phosphates. So over here, I need to have 2 phosphates, and right now I only have 1. So I'm going to put a 2 right here. That gives me 2 phosphates, but now it gives me 6 hydrogens. Over here I only have 2 hydrogens. So that means I need to put a 3 there, and now I have on the left side 3 calciums, 6 hydrogens, and 2 phosphates. And on the right side I have 3 calciums, 2 phosphates, and 6 hydrogens, and these are the same, these are the same, these are the same. It is balanced. So my final answer is this right here.